open your book to page 156. This is lesson 5.1. This lesson is on bar graphs. The bar graphs are used to compare amounts. And so if you look at it in your book, so this is an example of the bar graphs. So you use a bar. And all you do is learn how to read the graphs. Okay, so in example 1a, over here it says, examine the bar graph in figure 2. Okay, so that's this one over here. And answer the following questions. Okay, what was the enrollment in 1980? So you look up in 1980 and you go over here. So it tells you 7,000. So the answer is 7,000 students. Okay, and you go to the next one. In what year was the enrollment at 6,000? So to look, so you go 6,000 and go across. So the year would be 1970. Okay, and C, what year has the least enrollment? So if you look over here, this is the least, right? This one is least, and the year would be 1975. Okay, and you go to D. Okay, so look at the example D. It says, during which year did the number of students increasing? So by looking at a graph, which year is increasing? Well, so it would be from 1975 to 1980, that's increasing. From 1980 to 1985 is increasing. And from 1985 to 1990 is increasing. So your answer would be from 1975 all the way to 1990, they are all increasing. And then you go to E, which 5-year period has the largest increase? So which has the largest increase? The answer would be right over here. This has the biggest increase. So the answer would be 1985 to 1990 has the biggest increase. Okay. And so you go to F. On page 157 on F, it says, how much greater was the enrollment in 1980 than in 1975? So 1980 compared to 1970, so how much greater? It means what's the difference? So if you look at this is 7,000, this is 5,000, so it's greater by 2,000, right? 7,000 minus 5,000. So the answer is 2,000 more students in 1980. Okay, then G. So what percent of the increase in enrollment from 1975 to 1980? So this one you have to do a little bit calculation. Okay, so example 1G on page 157. So from the F, right? So from 1975 to 1980, the increase is equal to, so again, look at the graph, 1975, so the increase is equal to 2,000, okay? Now to figure out the percent, you have to divide by its original number. So original number is 1975. So 1975 is 5,000. So you have to use the 2,000 divided by the original amount. Right? Again, you start at 5,000 and you go up by 2,000. And so to figure out the percent, so it's called a P. So you can divide. Now you don't want to divide anymore, but actually you want to multiply by 2 because remember to get to percent, you want to make the bottom equal to 100. So if you multiply by 2, you get 40 over 100. So P is equal to 40%. Okay. So again, to convert to percent, you need to make the bottom equal to 100. Now, if you have a hard time doing that, then you can convert into decimal and just move 2 places over after that. Okay, so now let's go to example 2. Okay, so example 2, you have this graph over here, and you can go and answer the question like A. Okay, so if you look at example A, it says what gasoline mileage does car C get in a city? So here's a car C, and in a city, so you can look at 2 different colors. So the light blue is in a city, so you have to look at light blue. And if you kind of look over here, it's about 24, right? This is 20, this is 25, and just kind of estimate, so it's about 24. So the answer would be 24 miles per gallon. Okay. And then you go to B, okay? So so you're looking for what gasoline mileage does the car C has on the highway, okay? So you have to go back and look at the graph. So car C on the highway. Okay, so car C on the highway would be 30, right? 30 miles per hour, right? Okay, now go back and look at C. What is the ratio of C, or car C's gasoline mileage in city to mileage in the highway? So again, you look at car C and compare city to highway. So car C is over here, and okay, so again, so this is example 2, and so this one you have to do a little bit calculation. So 2C. Okay, so 2C. Again, you're looking for city to the highway. So the city is 24 miles per gallon. Per gallon. And the highway, again, if you look at highway, so it's 24 to 30. So over 30. So this cancel out. So reduce, you can divide by 6, so you get 4. Reduce by 6, you get 5, and this cancel out. So answer is 4 to 5. Okay? So it'd be 4 to 5. Okay? And so you can just kind of read this off and compare. So on D, it says, which car gets the best gasoline mileage in the city? Okay? So again, if you look over here, so this is car A, B, C. So answer is car C has the best gas mileage, right? Go to E, which get the worst gasoline mileage in the city. So looking for the worst one. So you can see that again here show A, B, C. So B gets the worst one, you get the least. Okay? And then you go to F, which car gets the worst gas mileage on the highway? So you're looking for the highway, for the worst one. Okay, so here's your A. So again, we're looking at the highway now. So A, B, C. So the worst one is A, right? It's have the least. Okay, so now go to example G. How many times greater is the gasoline mileage for car C than for car B in the city? Okay, so again, we're looking for car in the city. So if you look in the car in the city, so the C is about 24 and B is about 12. So the answer would be 2 times. Okay? So again, so you need to learn how to look at a graph. Now the things about graphing is that sometimes you can distort the graph by giving the false information if you don't start at 0. Like this one over here. These are the same information, but this one, it start at 30 and the numbers are really small increase. So it make this looks like really a lot. But if you look at graph correctly, like if you start at 0 and you even out evenly, so this does not increase as much. So this is kind of distorted. This one looks like it's about 3 times as much, but in reality it's not. So you have to be careful when you look at a graph so you don't get deceived.